Welcome to Energy Talks, a regular podcast series with expert discussions on topics related to power system testing, data management, and cybersecurity in the power industry. My name is Scott Williams from the podcast team at Omicron, and I will be your host. Hello, everyone. This episode examines the EN 50522 standard for earthing systems and its latest revision. For those unfamiliar with earthing or grounding systems, these systems connect specific parts of an electric power system, typically the equipment's conductive surface, with the ground for safety and functional purposes. The choice of earthing or grounding system can affect the safety and electromagnetic capability of the installation. Just so you know, earthing is the term used in European countries, whereas grounding is used in North America and other countries worldwide. Both terms mean the same thing. The EN 50522 standard specifies the design requirements for earthing systems and installations over 1 kV AC. It aims to ensure safety by limiting touch and step voltages. Touch voltage is the potential difference between a conductive part and where a person stands, while step voltage is between a person's feet. Two experts with extensive experience in earthing systems and the EN 50522 standard in Europe join me in this episode. They describe how the standard has evolved over the years and highlight what's included in the latest revision. First, I am honored to introduce Theodor Connor, who has worked for Siemens AG on network planning projects in Germany and abroad for 39 years. Theodor has been involved in planning transmission and distribution networks worldwide, planning and analyzing earthing systems, and investigating major network disturbances and blackouts. Theodor has held leading positions in national and international committees, including DKE, CIRED, SIGRA, IEEE, CENELEC, and IEC. Hello, Theodor. Welcome to Energy Talks.
Hello, Scott. Thank you for the invitation. It is really my pleasure to contribute and to send a spotlight on a dry and dusty standard, which has been recently renovated.
I am also honored to introduce Christian Raunig, who has worked as an asset manager at Austrian Power Grid AG, a transmission grid operator, since 2018. His focus is on earthing and interference issues. Before this, he studied power engineering at Graz University of Technology, where he subsequently worked as a university assistant at the Institute for Electrical Systems. He also worked as an engineer for protection and field control technology and as a technical consultant in the grids division at an association of the Austrian electricity industry. In addition to participating in national and European standards committees on earthing issues, Christian is chairman and representative in committees on neutral point treatment and grounding. Hello, Christian. Also a warm welcome to Energy Talks.
Hi, thank you, Scott. Nice to be here, and many thanks to Omicron to have the opportunity to participate in the podcast.
Thank you again for joining me to talk about the EN 50522 standard and what's new in the recent revision. So my first question is, could you both define what is meant by earthing and grounding, and what are the differences?
Yes, I think earthing and grounding will be the same, but the wording of earthing will be used in the European countries, and the wording grounding is used in, for example, the US and internationally.
We decided in Europe to use only the expression earthing.
Okay, so in today's episode, we discuss the EN 50522 standard for earthing and grounding and its latest revision. Theodor and Christian, could you please describe the EN 50522 standard?
Yes, definitely. The title is Earthing in Power Installation Exceeding 1 kV AC. So therefore, earthing is the wording, and power installations above 1 kV means high voltage. So we have a clear border to the low voltage. And this has to be seen in conjunction with the IEC document 61936-1, which is the general standard for installation.
The standard is important, especially for the perspective of a grid operator. So you have clear rules with the standard given for personal safety, for the technical functionality of the system. for the earthing systems. In the EN 5522, you have the minimum requirements for safety of people, for the safety of animals and the proper function, for example, other things in the substation. So you have standard who defines and listened all these requirements for the substations to operate the substation really safe for people, animals. The EN 55 is an European guideline. So you have the minimal requirements for whole Europe listed in the standard. And there will be also in every country, you have national additions to the standard. But I think every grid operator also has different requirements, different guidelines for how to build the earthing systems, how to deal with the design of an earthing system, which materials you will be used, which cross sections you will be used. So there are many, many different things that will be done different in every country, will be done different by every grid operator, for example.
Christian, in what areas does EN 50522 apply?
The EN 5522 applies for substation, including substation for railway power stations. This standard applies also for electrical power installation on towers, for small transformer stations. Example for switch gears outside of closed electrical operation areas. The standard also applies for one or more power generators located on a small area, on a closed electrical operation area. The standard also applies for electrical systems of factories, for industrial plants, the power installation of offshore facilities, for example, also for generation, transmission, distribution, or storage of electricity on offshore platforms. The standard also applies for transition towers between overhead lines and underground cables, but it does not apply for the cable or for the overhead line itself. Also excluded in the standard is the electrified railway installation on ships, for example, and test sites in laboratories.
Well, thank you for that. Theodor, can you tell us how long the standard has been in existence, as well as why and how it was created?
Well, this is a long story. In 1990, in these years, Europe decided to harmonize their standards. So at that time, countries like France, Austria, Switzerland, all these countries had their own standards. And so work started on Senelec to harmonize them. And in 1995, we started and we got in 1999 a document which had 100 pages of standard and 50 pages of national deviation.
Interesting.
And this was the reason that Senelec decided this is not a standard, and they called it a harmonizing document, a document to start to come closer together. Now, at the same time, on another level, internationally, IEC started to draw a document on installations of high voltage substations. And of course, this was now running in parallel, but internationally, we'll had to include the US, South America, Australia, China, and so on, with different views. So at the end, this European document and the international document were not running in parallel. And I got the task in about the year 2000 to bring these documents in a way, in a shape, that we can go for parallel voting, that the IEC document includes the requirements we need in Europe. And when I started this work, I realized that especially for earthing, something is missing. The philosophy of the US and of Europe is so different, we can't harmonize it. So into the IEC document, we put a so-called, I call it umbrella function, minimum requirements. And then I started in Brussels to ask for a separate standard for Europe. And this was the start of EN 5522. And this then we managed in the year 2010 to have the first standard EN 5522 on the table. And this was really something extraordinary because we had a standard of 70 pages and only 2 pages of national deviations, which means that in the meantime, countries really realized the benefit of having the same view, realizing that we are not so different. And we had more than 10 active European countries. So this is really a small success story.
Very good. And both of you refer to the standard as 5522, but is actually 50522. So 5522, correct?
Isn't it 50,522?
You could also say that as well, but that's a tongue twister. I dare you to say that 10 times fast. So for a deeper look into the EN 50522 standard, Christian, could you please tell us a bit about its structure and content?
Yes, the structure of the EN 5522 is generally divided into different chapters. For example, the scope of the standard will be described, the area of application, as I told you before, which areas are applicable for the standard. The definition of the terms will be one of these chapters. The index of the keywords and the description of the keywords. For example, what is an earthing, which different neutral point treatments dealt in this standard will be described. Also, the basic requirements in general will be described in this standard. The design of earthing systems will be described, how to install earthing systems. It is described how you deal with the cross-section, what are the minimum cross-section, for example, regarding the mechanical requirements, or how to avoid transfer potentials. It will be described how you have to measure earthing systems. Yes, there will be many appendix, for example, normative and informative, for example, where you can show how permissible touch voltages be calculated.
Okay, thank you, Christian. Theodor, what are the most important points or core statements that could be highlighted about this standard?
Well, thank you. This is an interesting point. I would start with the sentence, resistance is not the scale to judge the efficiency of an earthing system. Somehow this might sound provocative, but I'll come back to it. The standard has two basic requirements, and as Christian said, we are talking about safety. The first one are the requirements regarding the current. And these are load currents, but especially fault currents. And they have to be maintained in the thermal way, in a mechanical way, and sustainable, which means, for example, corrosion. The second one is related to voltages. And we are talking about the earth potential rise. We are talking about touch voltages and, in brackets, also step voltages. Now, in the end, this has all to do with body current, and also touch voltages only transferred the risk to the human being, which is the body current, into figure which is measurable, easy on site. So in the end, there is no requirement for a resistance in the standard, no permissible resistance, no maximum resistance. It is all about current carrying capacity and voltage maintenance, and maintain all voltages.
Thank you, Theodor. Now let's examine the specific content changes in the latest revision of the standard. Theodor and Christian, what is important to know about the recent changes?
Well, if you talk about a standard, especially a standard for substations which have a long lifetime, it is essential to make evolution and not revolution. So you have to maintain what is available and keep it and bring in new aspects if they are available. Here I have to add that we'll have a problem with the organizations that in the past, the 5522 included components from the IEC standard, international, and this was indicated by italic letters. So it was very obvious by reading the earthing requirements what is coming from the international standard. Now, this is no longer possible. There are copyright issues between Senelec and IEC. So we have now in the standard only references, which means you need to have both documents on the table if you work on it. So this is now a request to the national organization to assist, because for the users it's very difficult to have both documents and to read in one document and in the other document. So national organizations have to find a way to make it easier, the cooperation between Senelec and IEC.
Very good. And Christian, do you have anything to add?
Yes. For example, during the maintenance, there will be some new materials considered in the tables, for example, for the dimension of the cross-section. So, for example, stainless steel will be added in the tables. So we have new materials that will be used today for the building of earthing systems. Also, further information on reduction factors was added during the maintenance of the EN 5522 standard, especially some informations how to calculate the reduction factors of cable systems. There will be some important informations for this topic added in the standard. New measurement methods will be added. For example, the frequency selective measurement method. This is a measurement method that will be used today all over the world. For example, I was by a measurement this week in one of our new power stations, and we use this measurement method. For example, the distances you have to take into account during the measurements will be increased. Maybe some things like the earthing of fences will be described better in the version after the maintenance.
Theodor, is it possible to say today which topics will be important for EN 50522 in the future?
There are good news. The cooperation of this TC99X and Senelec, which is reflecting it, is very active, and they realized that there is feedback from users. So they founded a working group which is going into the issues like touch voltage calculation, like measurement on earthing systems, like details on global earthing systems, on foundation earth electrode, on reduction factor of mixed cable sections, on soil resistivity. And this is a chance to bring engineers from different countries together to exchange their experience and to filter which subjects should be part of the maintenance for the next version.
How should engineers go about working with the revisions to the new standard? For example, how can they inform themselves and put what's been defined into practice? Christian, do you have any thoughts about this? You had talked about actually starting to apply measurements that have been defined in the new revision in the field. What would you recommend to people to start using what's specified in the revised standard?
Yes, I think the standard will be very helpful for people who perform measurements. So you have some indicates how to perform the measurement, which measurement methods are available to make measurements on earthing systems. From my point of view, it's really important that somehow, for example, in the standard is described how you have to perform some measurements, that you measure the important points. For example, we have in Austria, in my field, the topic how much step voltages you have to measure, how much points regarding the touch voltages you have to measure. Where have you to measure these touch voltages? Is it in the area of the substation or is it outside the area of the substation? From my point of view, these points that you have to measure touch voltages outside the substation, that you have to check if you have some transfer potentials in the area of the substation, for example, over the low voltage connection, the so-called PEN conductor. I think this topic should be described a little bit better and more in the standard.
Very good. Theodor, do you have anything to add?
I'd like to add something. This is a good question. First of all, there are two aspects. First of all, that there is a battle between, let's say, consultants who want to make a standard more complicated because it's their business, and we have to be aware not to allow this. On the other hand, there are the users who want to keep it as simple and cost-effective as possible, but we are responsible for safety, and doing nothing for a long time could be a risk. Second aspect is about training. It's all about training. The subject of earthing is an issue where you need to have experience. It's not by just reading a book. And from my personal experience, I must say, I was doing the planning of earthing systems by starting with analyzing soil, making the design, having the interaction with the construction, and at the end, to make the measurements and eating the proof of the pudding. So by doing this test, I gain a lot of experience to make the right judgments in the very beginning. And as Christian said, you need to know where are the critical places outside. And this is by experience and is not part of a book which you can read and then you are perfect. The standard is putting minimum requirements. And this is one of the big difference to the US. The IEEE standard is a book you can read and you get training and is guidance. Now, this standard is just putting minimum requirements, commonly agreed minimum requirements. And it is not part to explain how it is done, in which way, and further on. The standard is available to have a clear limit to say possible or not possible. It is there to exchange products across borders from Germany to France or to Italy or from Switzerland to Portugal. So if you make a specification, a clear figure what to expect and what to do, that is the target of a standard.
Christian, did you want to add anything?
Yes, I think I have to add something from the perspective of a grid operator. The standard includes the minimum requirements. So for us as a grid operator, it's really, really important that we have these requirements so that we have from the point of the law that if we build some substations or some electrical systems, it is really important to have a guide, a standard with the minimum requirements. So we have listed in the standard what we have to do, that the substation, for example, is safety. And on the other hand, we have to do something for the long time planning, for example. We don't want to change the earthing system every 2 years, for example. The money also is a important thing for us, for example. So you can put many copper in the earth so that you have a very good earth resistance, for example, and all these topics. But this relation between minimum requirements, the money, and all these topics is really important for us as a grid operator. Also the legal points, so that we know if we have performed all the minimum requirements from the standard, so we can check these points and then we can say, okay, this substation, this electrical power system is safe for people.
Very good. Theodor.
Yeah, I wanted to point out again, we have to be very clear with our defined words. A guide is something which is nice, you may follow very open. A standard is a must. There's a big difference. And especially Austria is a very good example because this 55-2 is a law in this country. So the requirements in there are law. In Germany, it is assumed that if you follow the standard, that you are fulfilling all requirements. So in a critical situation, the judge will say, well, you followed the standard, so we are on the safe side.
A little mark to this. It was like a law in the past because of the copyright. Now it's not a law because in Austria we have the special condition that we have in German called Elektrotechnikgesetz. And to the law, we have a document, it's called Elektrotechnikverordnung in German. It's like a guideline where the standards which will be dealt like a law. So you have to take the standards like a law in Austria. So you have to deal with them. You have to consider this. And if you don't do it, there will be some very complicated situation. You must perform a risk analysis to show what you build, and with the measures you said that you will have the same security level like the standard. It's really complicated. You really have to show that you have the same level of safety as in the standard. If you apply the points of the standards, the minimal requirements, then you can be secure that this will be enough to fulfill the electrotechnical law in Austria.
Very good. So it's the same then as in Germany, where it is assumed if you follow, it is assumed that you have done all you can do. And you mentioned one expression, which is a large battlefield, which is risk assessment. But we excluded from this podcast. Perhaps another time we have to look for risk assessment.
Maybe that will be the next episode. I'll invite you both to that. Theodor and Christian, thank you very much for joining me in this episode to talk about the EN 50522 standard and the changes made in the recent revision.
So, Scott, thank you and Omicron. It was really a pleasure and we had a good discussion. I hope that this podcast will encourage users to give us their feedback on handling the standard, because we need feedback from the users. Or even that they want to contribute to work with us in the standard, that they realize that the standard is done by real engineers. So I really hope that we provide safety. Thank you.
Thank you, Scott, for the opportunity to be a part of this podcast, and also thank you, Omicron, and also thank you, Theodor, for this good discussion.
It was very good. Thank you both very much. And a big thank you to our audience for listening to this episode of Energy Talks. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, data management, and cybersecurity in the power industry, and offers you the matching solution for your application. For more information, be sure to visit our website at omicronenergy.com. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.